see a little bit left, and you'll see some little changes. But most of the changes are in 72 hours. So the clipping of those proteins, those big proteins, is most likely occurred. And with time, they'll slowly relax and fall apart. And then here comes calcium, and it's going to wedge in. But it's going to take time to do this. And so I want you to read the Wu and Smith paper and bring your questions back on Thursday. And I want you to also read the Gall et al. Paper and bring your questions, and the Kamari-Giesecke. I know that's a lot to read, and then we'll hit the two Nishimuras, which are easier. And then I'm going to bring the Sullivan-Calkins paper out light. But those three papers I want you to read. One of the things that Wu and Smith does is they measured ionic strength. And measure ionic strength, you basically measure the charge in a solution. So you have to centrifuge it down, pull the sarcoplasm out, and you measure the charge in it. Now you can measure the ions that are in it too, but it depends. There's lots of ways to do it. But what they found, what Wu and Smith found, is that at early postmortem, they were at 0.1, and you're going to check me on my numbers because I'm doing this off of recall. They were at 0.1 for ionic strength, and it went to 0.3. So there are more ions, and that correlated with increases in tenderness. Now, I used to give you the Kamari 1988 article, and I give Mohammed's a good friend of mine, so I'm allowed. I tell him that I tell this story because he spends some time in that article trying to disprove Wu and Smith, and he infused ions to create big differences in ionic strength, and then he said it didn't affect tenderness, and it didn't at 1 day, but it did at 14 days. And he just totally ignores that. It's in the chart and talks above it. And he still to this day, it's hard for him to swallow it when I say, but Muhammad, it did. It just takes time for that to happen. You know, and that makes sense, doesn't it? If you're going to loosen the structure, and we also know that it takes time for those ions. They don't just like whoosh out. You know, we lose that sarcoplasmic reticulum integrity slowly. It's a lipid bilayer. Things are slowly leaking. And so we end up, and the magnesium, it's probably there. It's probably more related to calcium than magnesium, but we don't really know. We just know that we have an increase in ionic strength that slowly happens over time. So slowly happens. And makes sense to me that both these things probably are working together. This is a very slow, not real marked effect. It's not like, bam, let's go from, 10 pounds of shear to 5 pounds of shear. This might be a 1 pound of shear change over, probably 21, 28 days. It's a slow effect. This is important because this can't happen and get the loose structure unless this happens, right? See how complicated this is getting? Why isn't it just calpains and calpastatins? That's why those genetic markers aren't accounting for all the variation. Anyway. So we also know that when we, again, make it a little bit more complicated, not only does the calcium go in there, but when those ionic strength, increasing ionic strength decreases the sphere of each charge on proteins. So this is a difficult concept. And it took me a while to really understand what was going on here. So calcium comes here and binds with that negative charge. Okay, so before calcium binds, and I have, let me just do a myosin tail here, and I have a negative charge here. And I dating myself. I know none of you ever watched Lost in Space. It's a very cheesy series from the 60s, but they always had force fields, and the strength of the force field affected whether the aliens in and attacked them. They were lost in space. They landed on different places, and different really cheesy aliens came behind fake rocks and tried to attack them in really bad costumes. Okay, but it was always the force field. There's a force field going to Hull. All right, so we know we have an ionic charge right here, right? It's one of the principles of chemistry, and that you have that charge, that ionic field goes out. So that the sphere of charge, sphere of each charge on a protein is pretty big, isn't it? But when calcium comes and binds to that, so then when we have calcium bound to that, and we have that negative charge, and here's calcium, the sphere of charge decreases, doesn't it? And that protein pulls more into itself. It also has, as far as the charges. So we know that when we have a drop in pH postmortem due to a decreased concentration or increased concentration of lactic acid, we also have an increase in ionic strength because we end up with these ions out there. And that those ions probably work in combination with proteases in helping to loosen the myofibular structure. And ionic strength most likely doesn't work as Z did, but it helps to loosen the structure of the protein so they eventually fall apart, right? Because it makes them not as strong. So I'm going to stop there. We'll pick up here, finish up, but please